want to talk about something called build transparency amongst enemies. So we're talking about software, the transparency of our software builds. So you're going to have a lot of talks today about how Nix works, different tooling in Nix. This talk is going to be a little bit more high level in that we're going to talk about the things that are possible once you take your full Nix pill and you adhere to this kind of model of building and distributing software. So, you know, Pavel gave us a great walkthrough of the Nix ecosystem. One thing I think he didn't mention is that Nix is really good at binary caches. So we talked about the Nix packages intermezzo. We have this cache called NixOS that provides all these Nix packages, and they all come from a GitHub repository. So you can use these recipes to build them, and they're distributed via a cache that we all use. We have to trust this cache, and in that sense, that's no different than any other package manager we use. So the Trustix project is something that came out of the Nix ecosystem over the last couple of years, kind of taking all these primitives that Nix gives us and tries to think about how we can make it radically transparent which packages we're getting in adversarial environments. You know, sometimes you might think this is a bit of a solution looking for a problem, but I don't think this is like a diss at all towards this project. I think they really took the ideas that Nix gives you and took them through a full logical conclusion. And I think this is kind of a problem set that we're going to have in Bitcoin, right? We're going to have to be radically sure that the cryptographic software we're using is the one we expect, and that we are operating in an adversarial environment when it comes to the packages we're sourcing. And yeah, so we should probably try solving this problem sooner rather than later. So before I tell you more about kind of how Trustix solves this problem, what's the problem we're trying to solve, right? The problem is that, as with Bitcoin and as with most things, trusted third parties are security holes. If you've used pip or npm or any package manager for your preferred language of choice, you're most likely just hitting pip install and running it and calling it a day, right? And you're assuming that it's the package you expect, and that's really it. And this is how most software in the world works. From a security standpoint, this is kind of not so great, right? You're obviously, you can, you know, NPM every other week has a story of malware that got into the NPM ecosystem, right? Because of a bad signature, because it got malwared or whatever. You know, Nix offers us some really good ideas to mitigate this, right? We talk a lot about reproducibility, meaning that, you know, if you have a given set of inputs, you can verify that the package the binary cache is giving you is the package you expected. You have this nice cryptographic signature that validates everything that went into this package, and you can be quite sure that what you're getting is the package you expected. You still have to rebuild it locally. Sorry? You could get a reproducible security hole, exactly. So yeah, there are a lot more problems here you can have, right? So if you know, the Nix package cache was somehow backdoored in such a way, or they changed the inputs for a package, you may not notice, right? Unless someone is checking all the reproducibility of the packages that are provided. Also typo squatting, yes, could do that. Yeah, I don't know how that fits into the Nix packages, but yeah, that's true. Right.
Ends up very reliably getting exactly the same derivation that you got.
Right. So if someone submitted a package that has like one letter off from the package you expect, and everyone starts downloading that, you'll be downloading a malwared package, right? This is also true in Nix packages, right? Also, it'd be pretty hard to see if the Nix package's signing key was compromised. Because of the way that the Nix package cache works, it's actually really hard to swap out the signing key and still be able to validate all the other packages that are supplied via Nix packages. Even worse, if the hardware that the Nix packages were built on was backdoored, you wouldn't know this either, right? So as much as like reproducibility is something that is a unique selling point to Nix and something that I think is a really good asset for open source development and security in open source development, it's really not a panacea, and there's a lot of other problems we need to be able to address. So, taken from the docs, I should duplicate my screen, but Trustix is a tool that compares build outputs for a given build input across a group of independent providers to establish trust in software binaries. So the only idea with Trustix is that if your packages are reproducible, and you know this, what you can do instead of trusting one cache is that you can simply trust many of them. Instead of having one single builder you trust, have an arbitrary number of builders, and then compare the build outputs of many of those builders. That way, what you're doing is that you're forcing someone who is trying to alter a package, alter a reproducible package, to kind of show themselves, right? If you assume that a certain number of the builders are acting in good faith, then it'll be easy to detect ones that aren't. If this sounds kind of conceptually simple, it's because it really is. But I think this gets us kind of very far ahead in terms of having an ecosystem, especially in an adversarial environment where you may not trust all the people supplying your packages. It gives us it really slows down limits the attack surface that people can have on the packages we're getting. So what does this look like, right? You might be a client, and you'll have multiple builders. What you'll do is that these builders will be building packages. Let's say they'll be building bitcoind. They will be providing the hashes of that build that they provide. If the package is reproducible, they're all going to be producing the same hashes. And you can decide what your metric of trust around these builders are. For example, for bitcoind or something that's quite sensitive, you might say that I want 10 out of 10 of the builders I'm listening to provide the correct hashes, right? If it's something that maybe you're less worried about, you could say, okay, maybe I'm just going to run 6 out of 7, or 2 out of 3, or 12 out of 17, entirely up to you, right? So you're observing these various builders, they're providing hashes, and you'd get to design your trust view on the packages that are provided, right? So this is basically what Trustix makes possible, right? It gives you a client on your NixOS machine to listen to multiple builders that are also running Trustix and providing these build logs to you, and you listen to whichever builders you want, and you configure your trust metric in any way you see fit, right? I like this a lot, and I think this is a pretty great idea because it forces we're bringing all the malicious actors onto our terrain, right? They have to undo a reproducible package that we define as reproducible, right? And I think this works quite nicely. I think a decent analogy might be that you know how Nostr, some of you are familiar with how the Nostr relay stuff works. You have a client listening to multiple relays blasting information, and it's redundant across those relays for a certain person's, wherever they're publishing their messages to. And then you set a filter over those relays for the specific type of information you want to receive as a client. Well, in a similar way, you have a client who's listening to a bunch of builders, and you place your filter on the amount of trust and which packages you want to listen to and the amount of trust you want to have in the success of those builds in an arbitrary set of builders. Cool so far? Yes, sir.
Why would you ever choose something that has 2 out of 10 or 3 out of 10? I mean, it seems like one difference is enough to raise suspicion.
Yeah, so the question was, why would you ever choose 2 out of 10 or 3 out of 10 or a degraded set of trust for a given package? Well, one answer might be that it's difficult. Like maybe reproducibility isn't always perfect. Sometimes there are transient errors. Maybe it's, this happens a lot even with Nix, right? You can go into the Nix packages issue repository, and there's packages that have kind of transient errors around reproducibility, or this package isn't fully reproducible, and we can't really find out why. Building software is difficult. Of course, the goal is obviously to get every single package at full reproducibility and the goal there would be, and so first of all, yes, I agree with you. You always want to get as much, you almost would never want to download a package that has 3 out of 10 builders, especially if, yeah, so you always want 8 out of 10 or 9 out of 10 for reproducibility, and I would agree. I would agree. Okay. Right. So if the build crashes, it wouldn't be published or available. Period. Right. So are there differences in the environment you're running it in if you're using it for an internal environment versus an external environment? Yeah, there may be, but it shouldn't affect the build. Like the whole point of building with Nix is that it's an actual sandbox, and that if that build is reproducible, then you're going to have the same output regardless of the method or size of machine on which you run it. So ideally, that wouldn't be a problem, I would hope. Excellent question. So that was, is there a mechanism in Trustix to try to track builders and view kind of whether they're being malicious, where they started being malicious? And there is, right? Trustix has a way of tracking each builder and their history and how they deviate from the global package set that you're following. So to your point earlier, like if we get to an open set of builders, you can track one of them that is continually trying to mess with the Bitcoin binary, and you can blacklist them or stop listening to them entirely as a builder, right? It gives you those kind of ways to and this is really like the whole point is like making it show the enemy, make them show themselves, right? Show when a builder is trying to mess with a reproducible package. And that's what that makes possible. Yes? Yeah, so the question was, like what percentage of Nix packages are actually reproducible? I believe it's somewhere around 96% last time I checked. I think it floats between 96 and 98%. And if it was 100%, would this project be useless? No, because the Nix package, you're still depending on the Nix OS cache itself as an individual cache. And that cache can be backdoored. Like it's not just because reproducibility is not the only thing that matters here, right? You would actually not know if the hardware or the signing key or even the inputs of new packages were altered in the Nix OS cache today, right? Reproducibility is great, but I don't think that every single package you download from Nix packages, you're rebuilding yourself to verify the reproducibility of it, right? So yeah, but also like the second interest in moving away from a single cache is that you force someone who's trying to mess with your software supply chain to go and chase 100, 10, dozen, 100,000 different builders around the world and not just one, right? And that buys you a lot of legroom. Yeah. Can you see the difference in the build logs between something malicious and something not? You can't, right? The only metric you're looking at is what the build logs that are published and what the hash was. That's it. So your metric is simply comparing to other people. So in that sense, it's quite arbitrary. But I would argue that if the packages are reproducible, then even an error that deviates from reproducibility can be malicious. Like you shouldn't have to tell the difference. In fact, something that is a mistake may be malicious, and you should consider it as malicious even if it's a mistake. You know what I'm saying? I think that's like a cool thing that Nix allows us to get to. Cool, love these questions. Thank you guys. So if packages are not reproducible and every builder is just coming out with different hashes for every single binary, this obviously isn't very helpful, right? Like we have to start with actual reproducible packages. But what it does do is give us a sense of like which packages aren't reproducible, which obviously wouldn't be super helpful. But if packages are reproducible, it allows you to observe these differences and detect them. And the trust metric, like we talked about a little bit, is subjective. Trustix has it doesn't force you to think like this package is safe, this package isn't. That's up to you to figure out which builders you're listening to and what your conditions for security around them may be. Obviously we should absolutely head for 10 out of 10, 100% reproducibility all the time if we can, but again, we're operating in an adversarial environment where that may or may not be true. Yeah. Okay, so the next part, right? So how does this project, what are the kind of the building blocks that went into this, right? As a builder, so imagine that you're trying to set up a builder, what do you need? You need an XOS machine. I should duplicate my screen, but running the Trustix daemon. So you have a Trustix daemon that is simply listening for builds on your machine. Every time you build something, the post build hook is going to tie it into the Trustix daemon. It's going to add that to your build log and publish it. We'll talk about build logs in a second because that's interesting as well. Yeah, you're going to configure two things. You're going to need two different signers, right? So just like in a classic Nix cache, you're going to have a build signer who's going to sign the packages that are built, and you're going to have a separate private key for signing your build log itself. All right, so there are going to be two different authentication things you're going to need. And then you just build packages. That's really it, right? Here's an example of kind of the, here's an example of kind of the configuration and what it looks like. You have 3 services. So you have the Trustix daemon itself, you have the Trustix Nix build hook, and the Trustix Nix cache itself. The Nix cache is a wrapper around the Nix serve module, which if you're familiar with Nix, it offers this ability to serve a binary cache on a server quite simply. It's quite literally 2 commands, and you're able to publish packages and send them out, which is kind of nice. And Trustix just wraps this a little bit. The build hook we just talked about. Whenever you build a package, Nix will pick it up and do something magic with it. In this case, it'll tell the Trustix daemon about it. One thing I want to point out is that the publishers, A, it's a list, so you can have multiple. But B, there's this attribute that's protocol, and the protocol is Nix. So one cool thing that they thought about is that, well, what if the underlying package building protocol is not Nix? What if it's Geeks or something else in the future? You can actually use the components of Trustix with a underlying protocol for building packages, which is quite a good foresight they had, I think. Append-only logs. So yeah, we talked about these build logs. What's happening is essentially if you have the mental model of a blockchain, like you've already kind of got it. It's not a blockchain. Obviously, a blockchain is a subset of append-only logs. It's a linear log. You commit to the previous entry in the log you issued, and each block or set of packages you're publishing is a Merkle tree that has a mapping of build inputs, build outputs, and the ones you have committed to that you've built locally on your machine. You can always detect a rewrite. If you're publishing your build log and all of a sudden someone is malicious as attacks this and decides to republish a certain set of packages, if you're listening to that build log, you can always, Trustix will tell you, hey, there's a fork here. Obviously, the packages are now no longer the history that I saw before. And if there is a fork, the packages before are still, quote unquote, safe to some extent. I won't go much further into this because there's a really excellent blog post by the authors and the tweet team about this called Good Things Come in Trees. Very cool kind of approach to Merkle trees, and I think if you're into this in Bitcoin, you'll see the familiar design there. Finally, while I was setting this up and working on researching this, one thing we could think about is at the moment you have independent builders that are publishing build logs directly to one client, right? So every single client has them individually. But it would be really cool if there was a kind of system where you could publish it in a really censorship-resistant way and broadly across redundant places, and a lot of clients could listen to them and compare all the build outputs coming from individual builders. Well, this is kind of exactly what Nostr is, right? I could totally imagine there being a publisher that publishes through has a Nostr profile, publishes through a bunch of set relays, and clients listen to the build logs from a variety of builders this way in order to really, really detect if there's any messing with the build log published by these publishers. I think it's a really natural fit, but to be explored. Okay, so kind of wrapping up here. This project was built in the Nix space and really not in the Bitcoin space, but I think the problematic that it solves is something that we're going to want to think about sooner rather than later. I think if people had any interest in pursuing this and thinking about what an architecture like this for package distribution might be, I think a solid MVP would be something like get 4 or 5 organizations in the space to run initial binary caches and try it out. I mean, it's just a Nix configuration I showed you, and the example in the documentation is built with Colmena. I built one with Morph on DigitalOcean. There's plenty of different ways we can figure out what the best way to do it is. And then start building packages. Start building Bitcoind. We have the package set from the Nix Bitcoin project to use. And yeah, I mean, first I think we should analyze the reproducibility of those packages and see which ones are 100% reproducible, which ones aren't. I think there's going to be a fair amount of work here. Either way, even if it turns out that we have to look at the majority of Bitcoin packages and make them reproducible, that's a really good thing to know and a really good thing to work towards, and something we should at least have some research done around. And yeah, finally, I think there should be some thinking around the client-side UX of this. Like, how do you engage with this arbitrary or maybe open set of builders? How do you look at your build logs? How do you deal with Nix packages in this kind of open environment? I think it's worth thinking a bit about the client UX. Right. So yeah, finally, just some thanks here. Like this project was developed by a developer at a company called Twig. If you've been in Nix or been around Nix, you've heard of Twig because they've contributed an immense amount to Nix over the years. At this brightest is Adam Huza, who was the lead dev on this project, and with a little bit of help from his team has been maintaining it. And I have to say this project is just a great example of where Nix development makes your developer experience really outstanding. Super clean project, really well organized. The docs are fantastic. There's protobuf definitions for the log API and the daemons API. I think if you wanted to explore this, you'd walk in and it'd be a pretty amazing thing. So, this was not an obvious thing to see as possible, to really have the knowledge and awareness of Nix and then go and take it to the next level to think about what this might look like in an open architecture takes a little bit of a genius, I think. So big shout out to him and his team for making this thing real. It was funded in part by the NGI Zero project, which has funded a ton of Nix work as well. It's a European Commission project around the next generation internet, Zero being their security-oriented project. And yeah, that's where the repo lives. If you guys have any interest in this kind of thematic and figuring out publishing packages in an open setting, feel free to come and chat with me. I'd love to jam on this any further. But yeah, that's it. Further questions? Yeah.
So, have any security issues? Has this detected any security issues? Like, have you found, through Trustix, have you found, hey, this is malicious? Are there any examples of that? So,
So, have I found any malicious examples through this? Not really, because I've kind of set up some toy builders on my own and kind of run the same packages that are already reproducible. So it's that'll just work. I think that's something you really can detect. I think we really want to detect this in a way more open setting is where it becomes useful for detecting malicious packages. In this case, the first thing we're going to detect is packages that aren't reproducible, in which case that's quite straightforward, and Trustix doesn't really help because every single builder you have is just putting out different hashes, and that's not very helpful. So no, I haven't really. Yeah. Yes?
Excuse me. How do you keep one Trustix node from perhaps gaslighting the others? Submitting the, yeah, it's fine.
What, the others? Sorry?
Gaslighting.
From gaslighting the others.
But it would just be a deviation. They wouldn't reach quorum.
They wouldn't reach quorum. Yeah, so I mean, there is no notion of consensus in this environment, right, which is interesting. How would you, so ideally, all the builders are operating independently, right? And they're not just taking in others' packages and republishing them. That is an attack vector, though, right? You could imagine a Trustix node that is providing packages, and really it's just taking packages from another node and republishing them with the same hash, right? You could imagine an attack like that, I suppose. Yeah.
Actually, I'm just going to comment on that because if you have a gaslighting node, Trustix node, then that for anybody who insisted on I want all of my Trustix nodes to agree, that does become a denial of service vector. Because now if I can just get any one gaslighter in there, everybody who has that policy on their end stops being able to use those packages, or at least the upgrades to those packages, until the gaslighter is identified and removed from their configs. So that's the threat model, not so much of running untrusted code, but rather denial of service for what would otherwise be trusted code except for the gaslighter. So,
yeah,
just a thought.
No, very interesting. Because it's more like a denial of service, more like they all take on the fake hash and.
No, any one hash. If your threshold is they all have to 100% agree, then any single one.
Oh, I see what you're saying. Sorry. Yeah. I got you.
It becomes like the U.S. Senate.
It becomes like the US Senate. So yeah, and again, like that's kind of why it's up to you to figure out what your builders are. And so, yeah, I mean, there's no mystery here, right? There's no protocol that is going to make you sure that you're getting the right packages. There has to be a number of set of builders that are actually building the packages and actually producing the hashes, and in good faith. And hopefully the amount of packages you're listening to are acting in good faith and not trying to DDoS, right?
I would still rather not get builds for a little while we found and shot the perpetrator of a node that was doing bad builds or sucking up malware or something like that, than I would to have to recall all the stuff that got built that was using bad code.
Yeah, totally. I think, Trustix conceptually brings to the surface a lot of these issues that could happen. They're better than knowing that they're happening than not knowing that they're happening at all, like it's happening today. So.
Hi there. Just to see if I got the high-level picture correct. So a builder doesn't need to provide a complete cache all the time, right? So it's basically just for the build logs would be enough, basically, right? To be a valid builder I can add to my list.
Oh, no, you would absolutely want each builder to provide a cache.
But this would kind of limit the amount of builders, because that's cache seems quite intense in infrastructure providing, like bandwidth or server capacity. So I cannot have somebody just running a Raspberry Pi basically also being a builder I'm adding to my list, because I would be just interested in his build log, right, to see if he can reproduce the same hash, and just to check on that. That would be the valuable information. So of course it's nice to have a lot of caches I can choose from, but basically I would also prefer having a wide list of builders I can just check on the hash. So is there at the moment the possibility to run a builder just for the build logs and not without providing the cache?
So you just do Nix cache enable equals false. Done. You're not serving packages anymore.
Okay, cool.
However, no, this is, I mean, I actually hadn't really considered this, but you're right, that you could have your little Raspberry Pis just building the build logs and proving that these packages are reproducible. Ideally, this is like we get to a place with packages where we know whether they're reproducible or not, and it's like moving forward, they're reproducible, call it a day. So I didn't see like a whole lot of utility around small builders not providing a cache, but providing a build log. In my mind, it was much more you'd have actually, it's more intensive infrastructure. Running a cache is hard work, and you have requirements that are important. So in my mind, it was more like we'd find a way to, zap these build caches and, pay them for the service they provide, which is providing packages. But that's a good idea as well. I had not thought of it.
Maybe this is so obvious that everybody thought about it before, but when I provide a cache, I provide a kind of download from my server infrastructure. Have you thought about torrenting this on a more like peer-to-peer basis, so nobody has the own hassle of a full cache, but just provides packages because he downloaded it just right now? Like Keat, maybe a more modern version of torrent.
Yeah. No, good question. Why not torrents? So I think the problem with torrents is that you build it once and then everybody seeds it. And so they're really just copying the file around, and they're not rebuilding it themselves. And I think part of the thing that's interesting about Trustix here is that you have multiple people rebuilding the thing and proving what they got out as a hash, and then you can choose where you select it from, right? So the fact that there's multiple work being done here in independent silos is a feature, not a bug, right? Whereas in torrent, the architecture is more like build it once, pass it around, whatever. I'm sure people have thought about this further than me, but yeah.
As a builder, is there something that protects me from malicious build scripts with Nix packages?
No, you get to choose what packages you build, right? So you are choosing the Nix package expressions you're using. So if you're sourcing them from the Nix packages repo probably, or a different repo or whatever, that's up to you to figure out. Obviously, if you have your fork of Bitcoind that is a slightly different build script or Nix packages expression for Bitcoind, it's going to result in a different hash, right? So that's up to you. Like, so I think one of the things that maybe that is useful is like Nix packages. We think of the cache and we think of the packages, but really it's a Git repo full of Nix expressions, right? And it's a big library of how to build the software, right? And so I think this is an asset. You have the one, like the canonical build script for Bitcoind that everyone can and should use because it's the reproducible one, the one that produces the same package every time. So I think everyone should probably try to use the quote-unquote canonical ones, right? Yes.
To the question of, can I protect myself from what I'm building? You still have the options of running it in a VM or in a container to the degree that you feel that those are appropriate protective models against your threat vector. So you can run, for instance, you could run Trustix in a VM or in an nspawn, container.
Totally.
So
Totally.
that should be pretty easy.
Anyone else?
Thanks, everyone.